All right, so we're back. We're looking at example 45. Notice that it says modified. This is actually the problem in the textbook that's a little different than what I have here. So that's what I mean by modified. All right, same objective as problem number 47, the previous one. Okay, we have two objectives. Describe the changes to the parent function for G and H. So we'll do that first. And then we want to graph G with relationship to F and H with relationship to F and look at the comparisons. Okay, so same objective. All right, transformations. Okay, notice the negative is a reflection, so you might as well go ahead and record that. It's a reflection in the x-axis because the negative is on the outside, okay, not with the x on the inside. Okay, we do have another transformation, and that's a multiplier on the outside of the function, so that's a vertical stretch or shrink, and because the value of 1/3 is less than 1, it's going to be a vertical shrink. So again, if we were to graph this equation, okay, in y1, and if we were able to graph this equation in y2, we should see that the original graph of f has been reflected and it's been made a little bit wider. And again, I encourage you guys to take the time to look at those comparisons and just verify that those transformations indeed are correct that we thought. Oh, well, how do you get it into y2? Okay, well, you can't enter function notation into y2. So let's come down here and do what we did in 47. So g of x is equal to negative 1/3 times f of x. So all we're going to do is replace actually f of x, okay, here. So you can use parentheses or brackets. Now this is calculator ready. You can type that into y2, whereas you couldn't have typed that into y2. Again, if you were to look at the comparison of y1 and y2, the f and g, okay, you should see that the original graph, y1, has been reflected, flipped, okay, and it's also made a little bit wider. That's it. All right, let's look at h of x. Let's list the transformations first and then get it calculator ready. Okay, so we have a 4 multiplier inside with the x, so we know that's going to be a horizontal change. How about an O? Goodness. Okay, stretch or shrink. Okay, well, it's just the opposite of the vertical, so if this was on the outside, it'd be a vertical stretch, okay, but it's on the inside, so if the C value is on the inside and it's a value greater than 1, then we call this a horizontal shrink. Pretty much just have to memorize those relationships. Okay, so again, what does that mean for us? Well, if we were to graph f of x in y1, and then we were to graph h of x in y2, we should see that it's been compressed, made a little bit thinner. Okay, well, how can we verify that? Well, let's get this calculator ready. So, like in the previous example, okay, if it's on the inside with f, then what we're going to do is we're going to take the value 4x and go back to the original function, and it's like you're replacing this x with 4x, but if you do it here, you've got to do it in for every x right here. So if it's on the inside of the parentheses, you replace in the equation that expression. So I'm building the framework, so it looks like I have x cubed, but it's not going to be x, it's going to be 4x minus 3, and it's not going to be x. I'm going to build the framework here. It's not going to be x, it's going to be 4x. I wouldn't try and simplify this at all with my calculator. It'll accept it just the way it is. So graph this as y1, graph this as y2, and observe that the original function has been made thinner. It's been horizontally shrunk. All right, what else can we do? Well, let's look at these last final 3 examples. All right, it tells us that g, the given function g, is related to a parent function. Okay, got it. And we're going to do parts A, B, C, and D. So A is to identify the parent function, describe the sequence of transformations, sketch the graph of g by hand, which we'll do, but you can use a calculator to verify. And then we're going to use function notation to write g in terms of the parent function f. Okay? So we've done all of these right here pretty much, and so now we're just putting them together in these last three examples. So part A, what's the parent function? Well, it's quadratic, so f of x is equal to x squared. B, describe the transformations from f to g, from here to here. A good rule of thumb is to start where x is in your new equation g and look at the transformation. So I would start with where x is, and that puts me on the inside of a parenthesis. So I know that's going to be a horizontal shift, not to the left, but to the right. So we're going to say horizontal shift right 4. So we took care of that. The square has no effect on a transformation because the square is actually part of the parent function. So we can kind of ignore that. Let's look on the outside of the parentheses. Okay, so that's like your c value being on the outside of your function. So that's going to be a vertical stretch Okay, it's actually by a factor of 2, but we'll just leave it at vertical stretch. Okay, and then the plus 3. We could tag the plus 3 at the end if we wanted to, and that's going to be a shift up 3. Okay, so we're done with part B. It looks like I've taken care of all the transformations. Right 4, vertical stretch, shift up 3. And again, the square is just part of the parent function. Okay, part C. I think I'll move and put part C over here. Give me a little more room. Sketch the graph of G by hand. It might be good to start with the parent function. So I'm going to do that, and I'm going to do it in a different color. So this is f of x equals x squared. And sometimes it's good to do the sketching like a couple steps. Take a couple steps to do the sketching. It might get to be too much if you try and do all the changes at once. Okay, so I'm gonna do that, I think. So what I'm going to do next is I'm actually going to do the vertical stretch, okay, first before I do the horizontal shift. So a vertical stretch, okay, by a factor of 2, a stretch means that we're going to stretch this graph up. It's just a sketch. This would just be the stretch vertically. Okay, and then I have 2 more transformations. I need to move my stretched graph right 4 and up 3. So I'm going to take every single one of these points and I'm going to move them one at a time, right 4 and up 3. And probably the easiest way to do that would be to take a pretty important point, a key point, which is the origin, and move it right 4 and up 3. So the vertex of the stretch graph is now right there. I think I'll do that in a different color. So the final graph, and I'm trying to maintain this stretch. That was supposed to be in blue. There we go. Ooh, I got it a little bit too wide. All right, but that's the end result. So we could call this g of x right here. All right, part D. Use function notation to write g in terms of the parent function f. So we've done that. So let's see. G of x equals, okay, the function notation is embedded right here. So the 3 plus can just come through. Okay, and then the 2 would be on the outside of our function. I'm going to change to the function notation. Okay, and then I also have the x minus 4 that I need to consider. So the f really holds the place of the square, the parent function. This probably seems a little bit uncomfortable because it is kind of abstract. Okay, but we just need to do a few examples and you'll be more comfortable with it. So let's look at 57. All right. Parent function, f of x, is x cubed. We can identify that with the exponent. you might think, okay, well, I'm shifting it right 1, which you're right, and I'm shifting it up 2. Okay, the constant on the outside, not with the x, is the vertical translation, and the constant on the inside with the x is the horizontal. So right 1, up 2. Okay, so I'm going to come over here and graph it. Again, you might want to, instead of just going right to the final graph, you might want to get yourself kind of set and draw the parent function. Alrighty, so let's draw the parent function first. So an x cubed graph. Alright, now looking over here, I don't have any stretches or shrinks, which I would take care of first. Okay, but because I don't have any, I'm going to go right to, I can double up on my translations. That's not bad. So I'm going to move this entire graph right 1 and up 2. So I think I can go right to the final graph. So I'm going to take a pretty key point, which is the origin, and I'm going to move it right 1 and up 2. So the graph comes off of this point. Okay, and then comes back down this way. I'm trying to maintain the shape because it is a rigid, these are rigid transformations. I'm not distorting the graph. All right, part D. Let's write an equation for g, okay, without the cube. Let's write it in terms of f, the parent function. So g of x equals, okay, and now right here, okay, this is all our function. This is our parent function right here. What do I do to this parent function to make it look like that? Well, I take the f, ooh, okay, let me see if I can fix that. There, I think we're good to go. Okay, so we want to take the parent function, f, okay, and wherever you see x, you would replace it with x minus 1. Okay, we don't need the cube because the f has the cube with it. Okay, and then we're going to add 2. Again, it seems a little strange, but remember, we don't need the cube here. We didn't need the square here. The f holds the place of the cube, but we do need to show the minus 1 to represent the shift right 1, and we do need to show the plus 2 to represent the shift up 2. Okay, let's look at another example. Parent function, absolute value. Transformations. Okay, well, I see a reflection, a vertical stretch, a shift right 1, and a shift down 4. That's going to be a reflection in the x-axis because the negative's on the outside, but we'll just put reflection right now. The 2's on the outside, not with the x, so it's going to be a vertical stretch made thinner. We have a right 1 and a down 4. I'm going to come down here. Okay, so a lot of transformations, so it's probably going to take us several steps to graph this. All right, parent function, absolute value of x. Hopefully it'll look better than the one on the previous video. Okay, so this is your parent function, f of x. This in red was also your parent function, f of x. Alright, so what should we do first? I try and save the shifts left and right for last. I try and take care of the more difficult reflection and stretches and shrinks first. Okay, so reflecting it means it's going to come down here, and a vertical stretch means it's going to be made thinner. So I'm going to reflect it and make it thinner. It's a non-rigid transformation. Okay, so I've taken care of these 2. Now I need to move every point right 1 and down 4. So take your key point, which is your vertex right here, and move it right 1 and down 4. And then off of this, I'll try and maintain the same shape as the green graph. Okay, so that's what the function would look like. And if you want to verify, of course, you can use your calculator as well. Okay, well, I think that's it. I think that was enough in this video, and the two together.